this idea haunts me for years now. And I was thinking the world will build it, but nobody's building this. So what do we do? Maybe that's me, right? Because it's me who cannot unthink this.
This is It's About Data, episode 73. Today we're talking with Nikita Shamgunov, co-founder of Neon and VP of Engineering at Databricks. Nikita, welcome. Thank you for taking the time to join us. Why don't you quickly introduce yourself to our audience?
Thank you for having me. My name is Nikita. I'm a VP of Engineering at Databricks. Previously, I ran a company called Neon, which was acquired by Databricks last June. And I have been building databases my whole life. So I started my career post-grad school at Microsoft, where I worked on a product called SQL Server. Probably many familiar with this one. And then I started my first database company called Single Store. It started as NemSQL. Turned out that was a poorly chosen name. And so we renamed it to Single Store over time. That company got sold to private equity for $900 million last year. And then in 2021, I started another company called Neon, another database company, which was a lot narrower and focused on Postgres, OLTP, which is operational workloads. And Neon took off very, very quickly. And then in about 4 years, we started to get a lot of acquisition offers. And eventually, there was an offer that was hard to refuse that came from Databricks, and it was closed in June 6th last year.
I remember that. And because I think we were you either closed during the Snowflake conference or your conference. I think you closed during the Snowflake conference, as I recall.
Yeah.
Rather interesting timing.
And then our conference was like a week or two after.
Yeah, something like that. But anyway, by the time that we hit by the time this episode airs, Lakebase, which is the fruit of that acquisition, will have been GA for close to a couple months. So I'd like to start off by asking essentially, what differentiates Lakebase? Because I mean, we have cloud OLTP databases, we have cloud lakehouses. What's different here?
So I think it's the evolution. We actually have not had a lot of innovation in OLTP for a long time. So if I were to point out in like this one great idea in OLTP, that would be separation of storage and compute, and the technology that I wouldn't say pioneered. I know databases too much. I think Oracle RAC pioneered it. But in the cloud, the technology that pioneered it is AWS Aurora, which is a good product. And for a long time, as Aurora started to gain more and more momentum, we started to see it in the market. Single Store was in the market. I was like, at least there should be an open source Aurora. At the minimum. At the minimum, the world deserves an open source implementation of Aurora. At maximum, this Aurora thing should be completely unbundled. And that kind of created my exploration of what Neon eventually became. And at the time I was running Single Store, I couldn't even think of running two database startups versus one. But then I left, joined Khosla Ventures as a partner, and then talked to Vinod Khosla and said, well, this idea haunts me for years now. And I was thinking the world will build it, but nobody's building this. So what do we do? Maybe that's me, right? Because it's me who cannot unthink this. So, and then we started working on this. And from the architecture perspective, I think there's been enough of a understanding in both myself, in my head, and the database industry in general, so that you can separate storage and compute for OLTP on top of an object store. So one big thing that exists in the cloud right now is that object store, S3, Azure Blob Store, and these things are remarkable. And the most remarkable things of the object store is 7 nines of availability. And therefore, you can rely your system of record, you can depend your system of record on that object store. and then outsource that, which historically been like one of the most important things in operational databases, to a cloud vendor, just because of that availability and then durability and like all these great properties. And of course, this thing is not fast enough for OLTP, which is operational databases, microsecond latency, millisecond latencies. Um, so you need to build more innovation to be able to run OLTP on the object store. So once we've recognized that, and actually we recognize that, I recognized that back as we were separating storage and compute in single store. And so that's why this idea was burning in my head. So from that point on, it was all about packaging. It was all about, okay, this is the kernel of the idea. There's a tremendous amount of technology that needs to be built. You need to build low latency storage on top of an object store to deliver on microsecond latencies for transactions. You need to build lots of layers of caching. Object store, and then we have this thing called page servers. There's basically on disk remote storage, and then on disk remote storage may or may not, depending on the day, needs a cache in that tier as well. And then you separate storage and compute, and your compute is Postgres, and we'll talk about Postgres a little bit in a second. So on the Postgres node, you definitely need an in-memory cache. You already have it. It's called buffer cache. But then on disk, you might also need that cache, and we call that tier local file cache. So lots of caches, and then you need to package it very well. And when you ask yourself that question of who are you packaging this for, the answer in operational databases is always we packaging it for a developer. And so we raised our flag and said, our user is developer. We're going to deliver our technology direct to developer. We have these great ideas about the architecture. So what's the next step? And the next step is like, we got to be Postgres. And it has to be Postgres because Postgres, as an open source database technology, I think already won developers and becoming kind of like Linux. So, but it's fairly complex. There's a lot of understanding how to use Postgres in the world, which is a great thing. Because otherwise, you build an operational database, and then you also need to teach the world to use it, and then you need to convince the world to rely on it. Postgres has already done this. So we're leveraging that fact that a lot of knowledge around Postgres is there. But what's missing? What's missing is a bar none incredible cloud service that's built for developers and not for infrastructure people. Because that was like an astute observation that AWS Aurora, RDS, Azure SQL, which is SQL Server, Azure Postgres, which is Postgres on Azure, they're all infrastructure. And when you build a developer first system or a developer platform, the properties are different. And the longer you kind of like pull that thread, the more they actually diverge. Where maybe some infrastructure foundation is similar, separation of storage and compute, this, that, but the consumption of this is kind of very, very different. And so then we put all of that together, right? We said our implementation of separation of storage and compute will be open source. And the moment we put it out, our GitHub stars started to go up. Okay, that's it. Like the world cares. We're excited. The moment we launched that, and then we said, the only thing that matters these days is the cloud. So we're only going to monetize in the cloud. We're never going to try to monetize our open source. So the moment we put our service in the cloud, we got people on the wait list. The moment we removed the wait list, actual traffic arrived and feedback started to roll in. The moment we turned on billing, the dollars started to. And from that, there was be like advancing this flywheel. The crazy thing that we always knew, and it's playing out right now, is that if you build your database on top of an object store, not only is just strictly better for running an operational database, and actually even performance can be better. And we can talk about it why. But the fact that data is in the object store allows you to open up something that has always been closed. So operational databases have always been black boxes, right? It's a thing, typically runs on one machine with a few read replicas or something like this, and with isolated copy of data, which is not available to any external analytics engine, other engine. So if you want to get kind of access to raw data, you can't. You can only go through the black box API that is exposed either on SQL. But guess what? Um, we we as like people who run databases, we don't like giving access to anybody the database, right? Because they will come in, they will steal the data or like misuse the data. They will run workloads that our database cannot handle. Will
Mess up consistency.
My application.
Yeah.
Like, don't mess with my database. That's basically the motto.
Stay off my lawn.
Stay off my lawn. And therefore, there's all this industry created to like extract data from an operational database, put it in a data lake, put it in a data warehouse. And so, like, a remarkable thing is if you store data in an object store, you can actually give access to that object store to downstream systems. And it allows you to avoid a lot of the headache of extracting the data or locking down the data. So that's why we call this product, the same product as Neon, but integrated with all the rest of the Databricks ecosystem, Lakebase. And then you pull the thread even further, because once you build a product for developers, guess what? The new developer is an agent. So nobody writes code anymore. And we were looking at traffic, and we were. I think the biggest realization, the biggest aha moment happened when Replit launched their Replit agent, and they launched Replit agent, and Replit is a vibe coding platform. For those who don't know, where you can go prompt and it will create you an app. And when Replit creates an app, it provisions a copy of Neon, because most apps need a database. Well, some apps don't, but like the majority of apps need a database. And I remember sitting there looking at traffic. And before that, we were hovering around 800 instances created on the platform per day. And then the day Replit agent launched, it was 15,000.
Wow.
So we went from 800 to 15,000.
Wow.
And I remember our team, jumping up and down, saying, "Hey, this is profound. Our user has changed. Our user is no longer a human. Our user is no longer a developer. Our user is now an agent because most of the code will be written by AI."
Right.
And since then, that prophecy is coming true. I believe more than 90% of the traffic on the platform is now agents. And if you, for example, if you just zoom in on the provisioning of a Postgres instance, you do it when an agent comes in and says, "Oh, I need a database," or a user, like anybody can come in and say, "I want a database." We do it when people want to create clones of that database or agents. And the reason to that is a sandbox environment. So you can create a clone of a database. We call it a branch. When this happens, we also create a Postgres instance. We also allow people to create a Postgres instance and then walk away. And in 5 minutes, we'll shut it down. But on the next usage, we'll bring it up. We call it scaling to zero. It saves money to our users. And so now also the traffic comes in and wakes up some of the Postgres instances we've scaled to zero. So if you add all of that up, that's 60 instances of Postgres per second. So on the day of a Replit launch, we had 15,000 a day. 60 Postgres instances per second is 8 million a day. And it's not a peak time. It's like if you measure 24 hours, we will be launching 8 million instances of Postgres a day, and a lot of them will scale to zero, of course. But that's the amount of traffic that we're seeing on the platform, and it's all driven by the fact that software is now built automatically, And as part of building software, those agents stand up databases, create branches, create snapshots, make mistakes. Once they make mistakes, they recognize they make mistakes. They want to go to the previous state. So the platform now supports those use cases and getting that incredible amount of traffic.
I mean, I thought it was really interesting when you start to talk about the number of hits against the database or against the databases, and your visual, your video zoomed out. That just seemed all too appropriate. All too appropriate.
Well,
I
that's
think
the magic of an Apple monitor.
Yeah.
Indeed.
Exactly. Well, there's must be some AI in that. Anyway, I think this really basically it makes for a very good segue here because you've opened a lot of doors here. Basically, using object storage and with the taking a popular arguably the most popular data open source database engine and reevaluating taking another look. Basically kind of sort of reinventing, the idea of the transaction database.
Yeah, let's just wrap this one up and we'll record another episode. So, yeah.
We'll see you shortly.